Welcome to the Growth Stack. Today in this video we're going to talk about a problem which recently appeared in a weekly contest on Leetcode. Let's quickly go through the problem. What the problem is asking for: given a pile of integers, we have to do k operations on that pile, and after k operations we have to determine which element can be the largest element on the top of the pile, basically. So an operation is defined as something like this, like if the pile is non-empty, meaning there are certain some elements in the array, we can remove the top of the array, which means the element at index 0. So if there are any elements that are already removed, we can add it back to the pile in a specific operation, basically. So either you can remove an element from the pile or add an element to the top of the pile from the elements that are already removed. So given this scenario, we have to find out the max element that can be at the top of the pile after k operations. So without further ado, let's try to understand how we can solve this, right? So if you look at the problem, right, so if you there are certain things that you have to note, right? So given an operation, right, so we can only reach till k plus 1 elements in the array. How is that possible? Let's try to understand. So basically after k operations, like to reach to k plus 1, we need to do k operations prior to that, right? So okay, let me put it this way. To reach to the farthest point in the array, we have to do k as many removals as possible, right? So if we remove k elements from the array, we can only reach till k plus 1. So we can easily say that the max element will always be among the first k plus 1 elements, right? Now let's try to understand the next condition, right? So the element at index k can never be, the kth element in the array can never be the max element. Why is that? So let's understand. So for any element in the array, right, so when we're at the kth position, right, the one thing that has to be understood is like we should already be doing, to reach to kth element at least, we should be doing k minus 1 operations already, meaning k minus 1 elements are already removed from the array. So we are only left with one operation, and the one operation can't be the removal, which makes the element at the top of the pile to be k plus 1, or it cannot be an insertion. The reason being, it can be an insertion, but it has to be among the k minus 1 elements. So the kth element can never be the max given this scenario, right? So if you understand after this one, then now let's move to the another part of the solution, right? So either k plus 1th element can be the max, in which case we just remove all the k elements and the k plus 1th element will remain at the top of the pile, right? So k plus 1 can be maximum, k can't be maximum, and then if there is any element which can be the max in the pile in the k minus 1 elements, right, so there is one condition that has to be satisfied, right? So at any point in the array which is to the left of which is less than k, the index, any element at index which is less than k should satisfy a condition. What's that condition basically? So let's say this is the KL, right? There's an element at index k, and we're looking at an index I, let's say. So to reach to index I, we should be doing already k minus I operations, right? So we should be already doing I minus 1 operations, right? So once I minus 1 operations are already done, we are left with we have to do some operation on the ith index, and whatever is left out after these operations, that is I operations are already done, so k minus I operations have to be done on the remaining elements. So the condition goes like this, like there has to be enough elements in the array for us to do these k minus I operations. Okay, let's revisit what I have just said. So basically, let's assume that the index is 3, right? So we have already done two operations to reach to index. I'm assuming index as 1 based. So we have already done 2 operations to reach to index 3, meaning we are only left with k minus 2 operations to do, and we'll exhaust 1 operation for the 3rd index, so which means we'll be left with k minus 3 operations. And for us to do k minus 3 operations, there has to be these many elements at least, right? So so if there are enough elements towards the right, we can say this operation is possible, and this index can be the max element. So we'll only consider towards finding out the maximum if this condition satisfies. Let's revisit a scenario where basically there are operations which can be bigger than the size of the array itself, right? So if there are 5 elements in the array and you are supposed to do 15 operations, you can always say there is some combination which will actually yield the max element in the array at the top of the pile. But there is one catch here. So there can be, like, if there is only 1 element in the array, like let's say 18. So if there is only 1 element in the array, if you have to do 1 operation, that can be a removal. If there are 2 operations, it definitely have to be a removal and an addition. So 2 is covered. And if it is 3 operations, then you have to remove once, add once, and run again remove. So basically what I'm trying to say is that if there is only 1 element in the array and you're supposed to do odd number of operations, you won't be left with anything in the array, in which case we can just return -1. So this is one edge case that we have to handle. Yeah. Now given this, let's dive into code. So as we have spoke already, so for any index to be considered to be part of being a maximum, we said that it has to satisfy certain conditions, and this function is wrapping those conditions basically. And after that, like we can easily, first things first, like we can weed out certain obvious cases. Basically, if the number of operations is bigger than the size of the array, and if we have 1 element in the array and there is odd number of operations, we can just return -1, which we recently discussed. In the other case, we can just return the max element in the array. Now what we have to do is basically loop through the elements in the array till we have k plus 1 till we cover k plus 1 numbers. So once we reach k plus 1 numbers, we can just break, because none of them after that are relevant to us. Right. And at every index we can just say whether we can consider that index to be part of the maximum or not. So let's try to understand what that check actually could be, right? So if the index is k minus 1, meaning it's the kth element in the array, we already discussed that it can't be the max element, so we just return false and try to identify how many operations are left out after this index and what's the number of elements to the right of that particular element, right? So if the number of operations remaining are 0 after such operations, we can just say that okay, this is already at the top of that file, so we don't have to do anything and we can just return true in this case. And if there are enough elements towards the right and that is bigger than whatever is required, right? So we have to do these many operations on to the right of those elements, right? So if we have to do 3 operations, let's say, there should be like at least 2 elements towards the right of the current element. Why is that? Basically we'll do one operation on the current element and the remaining 2 operations can either be like remove an element and the next operation is adding our current element, which will make it current element as the top of the funnel. So these are some conditions that has to be satisfied, and the remaining one will always return false basically. So let's try to use some example test cases which are already given and see if this code works with that, right? So this actually works, and let's try to submit, right? This works as well, pretty good. So we'll try to cover more problems going forward at the end of the contest. So please subscribe to the growth stack and come back. Also press the bell icon to get notifications for any videos that we do going forward, right? Thank you.